Hello, dear friends. Welcome to the Quantum Group. Let's see this question number 3.18 of Irodov. The question states, find the electric field strength vector at the center of a ball of radius r with the volume charge density rho is equal to a dot r, where a vector is a constant vector and r is the radius vector drawn from the ball center. So for this question, I would be needing the question number 3.16 of Irodov, the result of this. And I've already given a video solution of this. For the solution, you can go back to that video. But here, for solving this question, I will use directly the result obtained in the question number 3.16. So let me state this question, 3.16. It states, sphere of radius r carries a surface charge density sigma is equal to a dot r, where a is a constant vector, r is the radius vector of a point of the sphere related to center. Find the electric field strength vector at the center of the sphere. So in that question, this is a sphere, radius r, and it has a surface charge density sigma. There is a constant vector, this a, and at azimuthal angle theta, the position vector r is there, and at this point the surface charge density sigma is equal to a dot r, which can be written as a ar cos theta. So this electric field, because of this and because of that distribution, you can see that this is varying with cos theta. Theta is 0, so charge density is maximum here, and as we go from here to here, charge density gradually decreases. Here it becomes negative 0, and then here it is negative. So it is very clear in looking from this charge distribution that electric field is going to be along this direction, because here we can take a pair of dipoles like that. So electric field will be opposite to a vector, and we solve that electric field comes out to be E vector is equal to minus A vector R divided by 3 epsilon naught. So that is the result that I am going to use. So now look at this question here. There is a sphere, this sphere of radius R, and in the sphere there is a volume charge density rho is equal to A dot R is there. So we can build this sphere by many shells whose radius varies from small r to r, and here is that vector a. So this is composed of so many cells close to each other, and this is one of the shell whose radius is r to r plus dr. And I will take a general position vector r at an angular position theta. So at this point, the surface charge density is given to be sigma is equal to a dot r, like this. So what I want to write, I want to think this thing as a shell, and this is a shell and it's electric field, I already know. And the surface charge density at this point would be nothing but the volume charge density into the thickness of that shell. So sigma at this point is equal to, at this angular position theta, is equal to rho at that position into the thickness of that shell. So sigma is equal to rho dr, that is a direct result. And then we'll put the value of rho a dot r into, and dr is there. So a dot r is I've just rearranged that. I have taken dr inside that bracket, so that is a dr dot r, and this can be opened as a ar cos theta into dr. So here you can see that ar and dr are constant, and it is varying with cos theta, like this is varying with cos theta. So this situation, this shell and this shell is actually identical. Only thing is that whatever is here ar, that is in this case, that is a ar into dr, and the variation of charge density at the surface would be like the same. So now, because of this shell, electric field at the center will be along this direction, and let me call that electric field to be d vector, and the value of d. So if sigma was a dot dr, E was minus a vector r by 3 epsilon. So if the sigma is equal to a vector dr dot r, Compare again. The sigma is equal to a dot dr. Now in place of a vector, I have a vector into dr. Its direction is obviously along a vector. So because of this, electric field was minus a vector r divided by 3 epsilon naught. So because of this surface charge density, electric field dE would be minus a vector dr into r divided by 3 epsilon naught. And we can make this sphere composed of so many such cell, and because of each shell, electric field will be along this direction, and all these electric field will get added up to get the resultant electric field. So resultant electric field is nothing but the vector sum of all such little d's. So net E is the integration of d. So in the integration of d, I will take a vector minus a vector dot upon 3 epsilon outside, and inside there will be r dr, and I will have to add up from 0 to capital R, and this integration will give me r square by 2. So overall I'll get minus a by 3 epsilon r square by 2, and on rearranging I will get E is equal to minus r square upon 6x epsilon naught a vector, and that is my answer. Thank you.